Welcome back to the Math Professors. If you enjoyed content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to determine the point of intersection between two lines in three space. So let's get into it. Line 1 is given by x is equal to t, y is equal to 3 minus 3t, and z is equal to negative 2 minus t. And then the second line is going to give it in terms of s. So your x, y, and z in terms of s. Now, if I want to determine when two points intersect, remember that they have to intersect at some common point. So I need their x coordinates, their y coordinates, and also their z coordinates to be equal to each other. So I'm going to need x to be equal to x, I'm going to need y to be equal to y, and I'm going to need z to be equal to z. Now, that means the x of the first line, which is equal to t, has to be equal to the x of the second line, which has to be 1 plus s. Similarly for the y, so 3 minus 3t has to equal 4 plus s. And then last for the z's, minus 2 minus t has to be equal to minus 1 plus s. Okay, so we have to be careful with lines. Like, they could look like this when you're looking straight down on them, but then when you kind of look over, you can see that they've actually missed their z components. So what I'm going to do is I'm going to let their x's and y's be the same value, and then I need to check with this equation if they also do connect at z. Because it's possible they share the same x and y component or coordinate, but they might not share the z coordinate. So it's possible two lines don't intersect. So let's find the x and y that make this true. So what I'm going to do for the first equation or the second equation, what one's easier? I'm going to solve one of them for one of the variables. Now they've done that for us. So t is equal to 1 plus s. This is already isolated for t. So what I'm going to do is, it saves us a step. I'm just going to take that t and plug it into the second equation. So this is very reminiscent of what you do like in an algebra class, like a pre-calc class, when you're trying to find the intersection between two lines. So now this is only in terms of s. So distributing and then isolating the variable s. So the 3's cancel. So let's put this s over here. So minus 4s is equal to 4. So s is equal to negative 1, which means when I plug this back into here, it also tells what t is equal to. 1 plus negative 1. So in this case, t is equal to 0. Now, what that means is when t is equal to 0, it's going to give us a point, and when s is equal to negative 1, it's going to give us a point on the other line. So let's see what point we get for the x's. Sorry, for the first line. So when x is equal to 0, t is equal to 0. So this gives us 0. Let's see what happens when I plug negative 1 into this spot over here. Well, 1 plus negative 1 is going to be equal to 0. So I can see that 0 is equal to 0. So that means they share the same coordinate of 0. Now, similar for the y's. When you plug in t is equal to 0, this is going to be 3 minus 3 times 0, or just 3. And then when I plug in s equals negative 1, I'm also going to get 3. And then we also have to check it for the z's, and I'll do that over here since I've got the work done. So let's check that. So when t is equal to 0, minus 2 minus 0 better be equal to negative 1 plus s, which is going to be negative 1. So minus 2 is equal to minus 2. So you can see that both of these are going to be negative 2 at the same time. Okay, so let's go ahead and find the solution point. So our solution point. Now we're going to choose what line that we want to plug it in. So I'm going to choose t is equal to 0 because it's easier to evaluate something at 0. Or you can choose the second line and plug in negative 1. We know we're going to get the same x, y's, and z's. So really what I'm doing is x is equal to t, y is equal to 3 minus 3t, and then z is equal to negative 2 minus t. At t is equal to 0 is where these things are going to intersect. Or the second line at t is equal to negative 1. Like I said, it's your choice. So plug it in 0, we're going to get this. Plug it in 0, we're going to get 3. And plug it in 0, we're going to be negative 2. So I get the point 0, 3, negative 2. 0, 3, negative 2. So these two lines do intersect, and that is their intersection point. So if you like the content, please subscribe. Thanks for watching.